So I'm recording now. So welcome back to class, you guys. So I have something that I need to get off my chest. So you better strap in. I'm going to try and say this as kindly and as patiently as I possibly can. But you guys, so for those that there's one, two, three, four, five, there's 7 people out of 22 in the class that are doing their homework, they're getting their stuff done, they're working through everything that needs to be worked through, and the rest are waiting until Monday night to do your homework. That is not going to work, especially with this chapter, because this chapter requires you to learn a new tool and to learn a different way to look at graphing and shading. So it's all new. So you have to practice. So I was looking at our My Math Lab and kind of putting in grades and stuff at about, it was probably 6 o'clock last night. So like I said, 7 of you were great. You had both homeworks done. You had at least one of the quiz, you at least tried one of the quizzes, but the rest of you had nothing done. You hadn't even started yet. So I'm telling you right now, that isn't going to work. The rest we are now halfway through our semester. So we have 8 more weeks. You got to pick it up. You cannot pass this class by doing the homework, just getting through it. It will not work because everything we're doing is all going to be new from here on out. So you have to take the time to, even if it's 15 minutes a day, right before bed, jump on, get some stuff done, and then jump back off. But at least open your My Math Lab at least every other day to get your brain so that it is making the process smoother and smoother and smoother. Every time you do it, it's going to be smoother. So for those 7, you're doing a great job. Keep it up. For the rest of you, you got to pick it up. You can't continue to wait until 7 or 8 o'clock at night on Monday to get your work done. It's not going to work. Okay. Is there any comments on that? And I know life gets in the way. I do. I get it. Things happen in life and you go, oh, I ran out of time. But make the time. Make this class a priority because it does take time. It takes a lot of time to be able to get through it. Okay. So any comments? That was pretty nice, right? Nobody's face fell off or, I'll put you in your safe space, give you a puppy. Okay, you're awfully quiet today. I'm going to make you start talking to me. All right, so what we're going to do is we're going to continue on as far as the chapter 5 test. So what I'm going to do is I'm going to send it out and set it up on Sunday night. So that's the 22nd. And you will have a week to do it. Now, remember, there's only 4 questions. So you have a week to get it done. Do not wait till Sunday night at 10 o'clock to get to do it. Okay. It's paper. So it's a paper test. So you are going to have to you'll either print it and do it on the test itself, or you can look at it online and then do it on paper. Okay. So this is a paper test. So then what you're going to do is you're going to upload it. You're going to scan it and upload it just like you did the first test, and then put it into Canvas. Okay. And it's got to be scanned and saved as a PDF. Okay. So this will give you another day of practice to scan and upload your work. Okay. So I will open it on Sunday. It'll be open like 6 a.m. Sunday morning, the 22nd, and it's going to be due the next Sunday by 11:59 p.m. Okay, on Sunday the 29th. Okay, so you have 1 week to do it. On top of that, you are still going to be working in your lessons. Okay, we still will have we have three homework assignments and a quiz that's going to be due the next day on Monday the 30th. So this is going to be a really good way for you to practice getting stuff done early in the week. Okay, get the test done, get it done, turn it in, and then you can start on your homework. Don't wait until the end of the week to do any of it. Start early in the week and go on. Okay, so I'll send out an email stating, hey, the assignment for the test, the chapter 5 test is open. You have 1 week to do it, get it done, turn it in, and then scan it and turn it back in. Okay, so any questions on the chapter 5 test? Okay, and then this test is not on the schedule. I wasn't sure if I was going to do it or not, and I thought, you know what, this is such an important chapter that we're adding in a test to which actually helps in your average of the grades. So don't panic on that. It works. Okay, so let me share my screen so that we can get going. Nope, that's not what I want. For some reason, my computer, I had to restart the whole thing today because it was just being very weird. It wouldn't upload and stuff. So, okay, so remember, 4.1 was all about systems of equations and solving using elimination to solve where the two lines cross. That's 4.1. 5.1 is just learning to use the My Math Lab tool, learning to draw a graph and shade, because now you're graphing an inequality, right? You're shading right or left. And I'll touch on that again because I did have a question of the whole idea of shading. And then 5.2 took those two topics and blended them. Okay, so we added another inequality. So now we have 2 or more lines to graph. And we ended up with a feasible region. So that's the green. The feasible region is where the two shades or two lines overlap. Okay, the corner points is also added into 5.2. Okay, so not only are you graphing a line, putting in the shading, then you're finding the corner points, and the corner points are where your maximum and your minimum happen. Okay, so we have, if it's an unbounded region, like what's showing where the green is, it's fenced in, if you will, on 2 sides, and then it goes on and on and on forever. That's unbounded feasible region. When it's unbounded, you won't have a maximum, excuse me, and you will have a minimum. In this case here, you'll have a minimum but not a maximum. So when it's unbounded, you only get one. You only get either the maximum or the minimum, depending on where the shading goes. If it's bounded, like this one, where the blue is, that means it's fenced in all the way around. Either you have the restrictions and the line, or all the lines are fencing in, if you will, the feasible region. And bounded means you can have both a max and a minimum. All right. Now, the good news is the max and the min only happens at the corner points. That's the only places that it will happen, is on the corner points. When you're inputting the corner points for the My Math Lab, make sure you include, like on this one, 0, 0, right? 0, 0 is a corner point. Nothing's really happening there because you have 0 of each, the X, and 0 of the Y, but it is considered a corner point. So make sure you include that. Otherwise, My Math Lab marks it wrong. Okay, so any questions on bounded or unbounded? You guys feel like you have a understanding of that? So I need some reactions. Come on, thumbs up, thumbs down. Need anything more? Thank you, Mark. Thank you, Brianna. One more. Okay. All right. So it looks like we're good with bounded and unbounded. All right. So this is an example of a feasible region in the blue where it's surrounded by lines. Okay. So this is where you have to be able to look at your the different color lines and figure out, okay, which two lines are crossing. So in this this region up here, let me get my pencil here. This region right here, those two lines are the green line and the orange line. So that's this system of equations right here. So remember, that's when you're doing elimination, that's where the two lines cross. And that's what you're looking for here. You're looking for where do those two lines cross. In other words, what X and Y makes both of those lines equal, right? Both lines will be balanced, if you will. Okay, on this one right here, it's the orange and purple. So that's this system of equation right here. So again, you're doing elimination. You're finding out where do those two lines cross. And then the third set is right here. And this was the green and the purple. Okay, so that's why I use color a lot, because if it was all one color, it would be really hard to differentiate which line is which and which two lines are crossing. So, all right, so are we good with corner points? So I need some reactions on that. How are we doing? Everyone okay with the corner points? Okay, Dylan, Tiba, Bo, Mark. Anybody else? Anissa, thank you. All right, so for those of you who didn't respond, so let's see. So Orlin, let me ask you, are you comfortable with elimination? No, now Adam responds.
What happened?
Are you comfortable with elimination, Orlin?
Yeah.
Okay, very good. And are you comfortable with finding corner points?
I think so most of the time.
Okay, all right. So those two things are exactly the same, right? If you're comfortable with elimination, then you can find corner points. So that's what you want to keep in mind, is the elimination is how you find the corner points. Okay, so that's why I say you have to understand 4.1 to get to 5.2. Otherwise, it's gonna, everything's gonna fall apart. Okay, all right. So let me see. Okay, thank you, Sophia and Anissa. Okay, so what we're gonna do now, let me make sure, okay, we have those. So what we're gonna do now is we're gonna jump to 5.3. So 5.3 is what's called linear programming, but we're doing it with the geometric method. So the geometric method is what we've been doing. The only difference between 5.2 and 5.3 is now we have a function which is called the objective function. Okay, so this is where our minimize and maximize comes in. So this literally is the only step that we're adding. Everything else stays the same. Now, in my math lab, and I'll show this to you, in my math lab, it doesn't tell you to graph. It just says at what point is the maximum. Okay, that's all it says. It doesn't tell you to graph, especially on the word problems. So you have to graph to get the right answer. Okay, you have to graph to get the right answer. So it's going to be imperative that you have practiced enough to know, okay, I have to graph it on paper. And as soon as I get my answer, then I can figure out what my maximum is or what my minimum is. Okay, but you have to graph it to do it, because we're doing the geometric method. We're not doing the algebra method. We're not using technology. We're actually graphing, shading, finding the corner points, and then we're finding out what the maximum is. Okay, so let me show you the process. So I am going to, my objective function is, in most cases, it's a z function, but don't let the variable throw you. It's just the objective function. So when we get into word problems, we're going to look for the objective of a maximum profit. Okay, that's the objective. We want to maximize our profit or maximize our revenue. We want to minimize our cost, right? Because cost is what, as a business owner, what I have to put out in order to do business. Revenue and profit is the money that comes in. Okay, so we maximize revenue profit, we minimize the the cost. All right. So with this one, we're just going to take it step by step. So I'm going to identify which line goes with which. So this is my orange line. Okay, so notice how it's set up. We're going to minimize and maximize the objective function, subject to. So these are our constraints. Okay, these are the things that hold us back. And I'm going to show you this in a word problem. What kind of things hold us back? So in business, the kinds of things that hold us back is the number of labor hours that we have. Maybe our machine that we're creating, you know, whatever, customized t-shirts can only do 50 t-shirts a day, right? So there are going to be constraints in a business setting. You only have 24 hours in a day. Then it gets broken down to, okay, we only have 8 hours in a day. So those are constraints. You can only do so much in one day. Okay, so what you're going to do, so again, on paper, all right, you have to do this on paper. You're going to go through the same process. So I have the 2x plus y is less than or equal to 20. I'm going to find my intercepts. So I cover up my 2x. That means y is 20. I cover up my y, which means x is 10. Okay, and again, whichever one I cover up, that's my 0. And then whatever variable is left, that's the intercept. Okay, so I'm going to go ahead and write this here so that we have them. All right, and then I'm going to do, I'm going to graph each one. Now, one thing that you can do, especially as you get into more and more lines, is you can go ahead and go through each of the lines and get your intercepts. And the only reason why I would suggest this is because you have to know how spread out your values are. Notice there's no values on this graph. I have to put them in. Okay, so cover up my x term and I get y is 36. Cover up my y term and I get x is 3.6. Okay, and that's fine. Because I'm doing this on paper, I'm good. I can have decimals and fractions. It's when you get onto my math lab that you have to have whole numbers, and I'm going to show you how to do that. Okay, so this one is my whatever color that is, purple. So I have 0, 36, and I have 3.6 and 0. Okay, and then this one is going to be my green one. And again, the only reason why I'm setting this up now is so that I can set up my graph. So I cover up my 2x and I get my y is 7.2. Cover up my y and I get x is 18. Okay, so any questions so far? How I got my intercepts? You guys feel pretty good about that?
Yes, ma'am.
Okay. All right, so now I'm going to graph. So now I'm going to put my values in and get my graph set up. So my highest y value is 36. Okay, so that kind of tells me, all right, I have 1, 2, 3, 4, 5, 6, 7. So 36 divided by 7, 36 divided by 6 is 6. So each one of these are going to be 6. So 6, 12, 18, 24, 30, 36. Okay, and then the same thing on my x. My highest x is 18. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I can do it by twos. So 2, right? 4, 6, 8, 10, 12, 14, 16. Yeah. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And all this does is it allows me to set up my intervals on the side. That's all this is doing. All right. You can do it by 2s, you can do it by 5s, whichever way you want to set it up. What I would suggest is keep it as large as possible, because the more it's spread out, the easier it's going to be to see it. Okay. All right. So now I can start graphing. So my orange one is 0, 20. So about right here, because it's by 6s. So 6, 9, 12, 15, 18, 21. So it's going to be right about here. And then 10, 0. So I'm going to try and do this with a straight line. Sometimes it allows me to. And I'm going to put 20 here and 10 here, just so I know what the numbers are, right? They're here also, but it kind of helps me to see it. Okay, so now I'm going to shade. So 0 is less than or equal to 20. So this is a true statement. So I'm going to shade down here. Okay, now, Santiago asked me a question and about shading. So here's the idea. Remember, what we're doing is we're looking for which points, right? What series of points make that particular inequality true. Okay, what is the solution? And remember, with the inequality, there's lots of solutions. It's not just one point. There's a bunch of points that will make that inequality true. So literally what I'm doing is I picked 0, 0 because it's the easiest one to use. I can pick any point I want. If I picked this one, which would be 3, 6, and plugged it into the 2x plus y, I would see, and I'll show you, I would see that, oops, it makes this statement true. Okay, so if I pick this point right here, 3, 6. So my x is 3, my y is 6. And what I'm doing is I'm saying, does this make this true? So 6 plus 6 is 12. 12 is less than 20. So the point 3, 6 is included in my solution, right? Well, the reason why I pick 0, 0 is because it's much easier to work with. Right? If I go 2 times 0 plus 0, is that less than or equal to 20? Well, yes, it is. I don't have to do any calculations. And that's the only reason why I use 0, 0 as my test point, because otherwise I have to actually do calculations. Okay, so the test point 0, 0 is your best friend. It makes your life so much easier. You can use other test points if you want, but you don't have to use 0, 0, because if 0, 0 is included in my solutions, then every point on this side of the inequality is also included in the solutions. Okay. So any questions, any other questions on the test point? And Santiago, did that answer your question? Thanks, Santiago.
I have a question.
Yes, go ahead, Sophia.
So I understand like how you would have to put in the origin. Well, that's the easiest point for like to get the shading.
Right.
But what were you doing with like when you were plugging it in with you know, two parentheses 0 plus 0, like that?
Well, that's where I'm plugging it in. That's
Just
why I get the 0 is less than or equal to 20, because this is my x, this is my y. So x is 0, y is 0. So I'm plugging it in just like I did on this one. I plugged in 3, 6 where x and the y are.
yeah. Okay,
So
yeah.
this part right here, I was just showing you why I'm getting 0 is less than or equal to 20.
Okay, yeah, I understand.
Okay.
Mhm.
All right, any other questions on the test point? Because I want to make sure that that's clear. Okay, so now I'm going to do the purple line, right? So the purple line is 0, 36. So I have a point up here and 3.60. So here's 3. So it's going to be just to the right of 3. And then again, I'm going to put in my straight line. I don't know how to make this not be so. Sophie, restrictions and boundaries, the same thing. Restrictions, the restrictions are the boundaries, right? And you'll see that once we get this all shaded in. So let me finish this, and then I'll talk about what restrictions and boundaries are. They're the same thing. Okay, so again, I'm going to put in my test point. Oops, I wrote the inequality wrong. So 0 is greater than or equal to 36. This is a false statement, right? So again, what that means is this 0.00 is not part of the solution. So I'm not going to shade below the line. I'm going to shade out here, because it's away from the 0, right? And again, if you aren't sure that you're shading right, pick another point. What if I picked this point right here? Right, so X is 9. Move this over. X is 9. And Y is 24. So if I put that in here into my inequality, does that make this a true statement? So I had 90 plus 24 is 114. This is true. So that's why I'm shading on this side, because all these points on this side of my line make the statement true. Okay. All right, and then the last one. So I have 0 and 7.2, so it's about right here. And I'm going to put that in there. And then 18, 0. There's that line. Okay. And then I'm going to test it. So 0 is greater than or equal to 36. Again, that's a false statement. So I'm going to shade above the line. Okay, so I didn't shade very well. So let me highlight where all three are interlapping is right here. Okay, that's where all 3 are interlapping. So my corner points are where the purple and orange, the green and purple, and the orange and purple are let me get rid of all this, are intersecting. Okay, so let's walk through what we just did. Let's stop there and walk through what we just did. Because I do have it, you know, some of you are like, oh, I need steps. So step 1 is graph the feasible region. That's what we just did, right? We found the intercepts. We tested to see where to shade. And the one thing I did not do, which you're supposed to do first, is put in my restrictions, right? Here's my X is greater than 0, and here's my Y is greater than 0. Okay, which in this case, putting these in, it will restrict the shading into the first quadrant, but we can see it's restricted even more into this little triangle area. Okay, so then what we're going to do is we're going to evaluate the objective function. at each corner. So I have to find the corners, right? The corners are going to be super important for me to find. So how do I do that? I use elimination. All right, so this is, let's see, do this. This is where the orange and green or orange and purple meet. So my orange is 2x plus y. And again, I'm done with the shading. I don't need to worry about the shading anymore. Is equal to 20. Good to see it. And then the purple is 10x plus y equal to 36. Okay, that's this where the orange is. That's so we can kind of identify it. Okay. Where the green is, is that doing that? Where the green is I have the green line and the orange line. Okay, and then the last corner point, I'll do it in blue, is where the green and the purple are. So green is 2x plus 5y. And then the purple is 10x plus y equals 36. Okay, so we have to do elimination, and this is finding our corner points. So there's that one, and this one is this one. All right, so that's how we're finding our corner points, is we're identifying which two lines are crossing and then go from there using elimination. All right, so any questions on that part? Identifying which two lines are crossing and knowing which inequalities to use. All right, so if you are not asking questions, that means you all understand it. So if any of you have a question, please, please, please ask it now, because if you have a question, I guarantee you somebody else does too. All right, never hesitate asking a question. And I try to give enough time, because I know there's a little bit of a lag time. I try to give enough time to let you guys, unmute yourself and then ask me. But interrupt me. I really don't care. Interrupt me. I'd rather you interrupt me than have a question and me keep going. All right, so here we go. We're going to do elimination. And remember, elimination is finding the corner points. That's how you find them. All right, so again, when you're taking notes, you should always have key terms. Corner points equals elimination, right? That way you don't have to read through your notes and try to figure out, what elimination is all about. You have it right there. Corner points equals elimination, okay? All right, so here we go. So I'm gonna eliminate the y, which means I'm just multiplying everything through by -1. Y's cancel. I end up with 8x equals 16. So x equals 2. Then I'm going to plug this back into either one, doesn't matter which one of the originals. And I get 2 times 2 plus y equals 20. Notice I'm using the original function. I'm not using the one where I multiplied through by negative. So always go back to the original functions. So I have 4 plus y equals 20. So y equals 16. Okay, so this should make sense, right? So when x is 2, y is 16, and that's pretty close. All right, so your graph should always, always, always be pretty close to what the answers are. So my first corner point is at 2 and 16. That's where the orange mark is.
Miss Manchester?
Uh-huh.
For like the first part, like the 2x plus y, and where you put the negatives, it would normally just have the parentheses with it, right?
Yeah,
'Cause
so what I did is because I'm just multiplying by -1, right? All that does is it pushes the negative through. It just changes the sign.
Okay.
Okay.
Yeah.
If I wanted to get rid of the 10, I could have multiplied, or I'm sorry, the 10x, I could have multiplied by a -5, right? Then I would have had -10x minus 35 equals -100, right? And then the x term would have gone away. But because it's just, you always want to, math is always about working smarter, not harder. Right? You should always take the easiest path when you're working through the math process, because it's a process, right? You don't want to get bogged down here, which could cause problems later, right?
Okay, yeah.
Okay, all right, so same thing here. See, I have two positive 2x's. So I'm just gonna, and I'll go ahead and do it so you can see it. I'm gonna go ahead and multiply through by -1. So just like on the first one, all that does is change my sign. That's all it does. Okay, so my 2x goes away. I end up with -4y equals a -16. So y equals 4. And then again, plug it back into either of the originals and solve for the other one. And why the reason why I'm multiplying by -1, are you talking about the second one or both?
I'm talking about both.
Okay, the reason why is because I want to eliminate, right? So I have to have one negative and one positive of the same thing. So on this first one, I wanted to eliminate the y's. So when I multiply by -1, I end up with a negative y in the orange one and a positive y in the purple one. And then I can eliminate it.
Okay, I got it.
Okay, and then same thing with the second one. I wanted to eliminate the 2x. I just multiply by -1. It just makes it easy. It gets rid of it. I don't have to do any calculations. It just changes the sign is all.
Okay, got it. Thanks.
Okay, and then my second corner point is when x is 6, y is 4. So that's for this one. So let's look and see, does it make sense? So here is 6. Here it's a little bit below the 6 on the y, so we're close, right? And again, that has to do with the angle that my lines are being drawn, but it's still close, right? If my point was way up here, then I'd know something's wrong. But if I'm close and the graph is showing that it's close, then I'm good to go. But this 6,4 is accurate. That's why you never look at your graph and try to get the answers from the graph. You always, always, always have to show your elimination, because the elimination is the mathematically correct corner point. Okay. All right, and then the last one, I'm just going to get rid of my y. So I'm going to multiply through by -5. Why did I pick y? Just, I don't know why. I just did. So I end up with -50x minus 5y equals a negative, just because I'm making myself work way harder than I probably should have. So now this one's gone, right? The middle, this one right here is gone. So 2x minus 50x is a -48x. The y's are going away. And then negative 180 plus 36 is 144. Negative. And then negative 144 divided by negative 48 is 3. And then plug it back into either one. And I get 2 times 3 plus 5y equals 36. So my y equals 6. So my x is 3 and my y is 6. Okay, and again, here we go. Look at your graph. It's close. Here's 3 right here. So it's right there. So we're close. So those are your corner points. Okay, and again, it's the corner points of the feasible region, right? I don't care about corner points here because that's not touching my feasible region. I only care about the corner points on the feasible region itself. Okay.
Miss
So,
Manchester, I have a question.
Yes.
Sorry.
No, ask.
On the second equation where like it was basically like the second part 2x plus 4 equals 20, and how you were
That's a y.
for
For right here?
oh no, below that.
Oh, here.
2x plus
Oh,
4.
right here. Okay, gotcha.
And like how you got 2x equals 16, wouldn't that be like a 8?
No, what's 20 minus 4? Oh, here. You're right. 2x equals 16. Thank you. Yes. See, you got to pay attention, you guys. You never know, and I'm going to mess it up. 2x equals 16, so x equals 8. Very good. So when y is 4, x is 8. See, that was going to cause a problem later. Good catch, Sophia. Thank you. Did I get all the other ones right? 16 divided by 8 is 2. 16 divided by 4 is 4. 16 divided by 2 is 8. 140, let me double check this one. 144 divided by 48 is 3. And then 30 divided by 5 is 6. Okay, we're good. Okay, so anything that we've done so far, you did in 5.2. Nothing new. You found the intercepts, you graphed your line, you used your test point, you shaded, then you did the same thing on the next line. You found your intercepts, you graphed the line, you used your test point, you shaded. Third line, same thing. You got your intercepts, you graphed the line, you used your test point, and you shaded. And then once you shade and all 3 shades are overlapping, that's where your feasible region, and this one is bounded, right? It's got fencing all the way around. And then we find our corner points. Nothing new. Everything you just did is from 5.2. The only new thing is now using the corner points to evaluate. So our first corner point was 216. Our second corner point was 84. And you saved me, Sophia. And the third corner point was 36. Okay, so this right here is the new step for 5.3. This is the only thing that's new for 5.3. Okay, so we're going to evaluate the corner points. Thank God we do not have to evaluate anything within that feasible region. We only evaluate the corner points because the maximum and the minimum only happen at the corner points. Okay, so we only have to, we go from an infinite number of solutions to 3. The 3 corner points are where our max and min is going to happen. Okay, so what we do is we plug our x and our y into this objective function. So it's going to be 3 times 2 plus 16. So 6 plus 16 is 22. Then we plug our 8 and our 4 in. So 8 times 3 is 24, plus 4 is 28. And then we plug our 3 and our 6 in. So, excuse me, 9 plus 6 is 15. Okay, so remember, we were looking for our maximum and our minimum, right? So our maximum happens when X is 8 and Y is 4, and our maximum is 28. That's our highest number. Our minimum happens at 3 and 6, and our minimum is 15. It's our lowest number. So this again is our new step. That's the only thing we're adding to 5.3. Okay. Any questions? All right, hopefully what you're doing, and again, I'm not super confident because there were so many of you that waited until Monday to do your homework. The process will get smoother and smoother and smoother. I can go through these fairly quickly. If you're having to look at your notes and what am I doing next and what am I trying to find next and what's the next step, that's going to slow you down. So that's the other reason why I wanted to give you a take-home test. So there was no time restriction on it. You have a whole week to do it. You can do 1 question a day over the 7 days and you will get it done. Okay, so you can take your time, you can really pay attention to it. But when you take the My Math Lab test, that one's going to be timed and there's going to be graphing on it. Okay, so that's why I wanted to give you a chance to get a good grade on this first. It's kind of like a sub-test. I'll call it sub-test number 2. So it's just that section. And then the real test number 2 on My Math Lab will be timed. So that's why you want this to be smooth, very, very smooth. And again, all these assignments through chapter 5, 4 and 5 are unlimited. So that's not meant for you to rush through. It's meant for you to practice and practice and practice and practice. Anwar, yes, the subtest does count as a test grade. So instead of 4 test grades in this class, now you have 5, which actually helps with your average. Okay, so and because there's only 4 questions, you either know it or you don't. So please put your all into it and make sure that you really, really, really understand this. This is a super important section in this class. Okay. All right. So I already answered this question. So determine the optimal solutions. The minimum is 15 at 8 and 4, which again, Sophia, you saved me. If that 8 hadn't changed, we would have had the wrong answer. And the maximum value is 28 at, oops, sorry. The minimum is at 3.6 and the maximum is at 8.4. Okay, so when you look at this graph, and we're going to get into an application, right? There's going to be an application to this. When you get into this graph, this point right here, this 8.4, this was our maximum, right? We have 8 of whatever our X values are and 4 of whatever our Y values are. That's going to give us our maximum. At the point 3.6, which is right here, this is where our minimum happens. Okay, the point 216 is it's in the middle of it, right? 216, the value was 22. So it's not a max or a min. It's just an interim value. Okay. All right. So let's walk through this. I'm going to give you some time, right? So take a look at this. And as you get answers, right? So how are we going to do this? So I'm going to have you write your answers in the chat, and I want everybody to do it. All right. So right now, just take your 6x plus 2y greater than or equal to 36. And all I want in the chat is, what are your intercepts?
Was it going to be for all three or just the first one?
Just the first one. Just the first one. Because I don't want to get confused as to which ones are which. So only put your intercepts in for the very first 6x plus 2y greater than or equal to 36. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 of you. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of you. So keep putting your answers in. If you've already done it, your answer is correct. Okay, good. Douglas, Anissa, good. David, very good. Okay, so it looks like we got that first step down, right? So I'm gonna go ahead and put in my my restrictions, right? So I'm gonna do this just so I don't forget it. So this is my first quadrant restrictions. And I'm gonna use this one as my yellow. So we have when x is 6, y is 18. Cover up my y. When y is 0, x is 6. Everyone good? Okay, and then the test point is 0 is greater than or equal to 36. That is a false statement. So I'll just go ahead and do this. Let's see. We're gonna do 8. All right, so 20 is going to be our highest y. So we have 0. Let's see, we're going to go.
If it's false, do we shade above, right?
Well, you shade on the side of the line where the 0, 0 is not sitting.
Got
So
it.
usually that's above the line. Yeah. I don't like using above and below because you'll see on this one, the y is less than or equal to 20. There is no above or below. So that's why I say just wherever, if it's false, wherever that 0, 0 is, you're going to shade on the opposite side. All right, so I'm going to go by 5s. So 5, 10, 15. I don't like that. That's going to be too crowded. I'll go, let's see, 1, 2, 3, 4, 5, 6. I'll go by 3. So 3, 6, 9, 12, 15. No, I need a 20. That's not going to work. So don't get bogged down on this. I'm trying to make this, I'll just go by fives. Then I'll have it all. And then my Y or my X's, 16 is the highest, so I can go by fives again.
On the quiz and test, will we
Mhm.
have to write our own numbers like this on the
On
graph?
some of them, yes. Some of
Okay.
them, I have, let me double check. Yes, so 2 of them have the numbers there and 2 of them they don't. And I don't care how you spread it out. Just make sure that you spread it out enough to where you can see the lines, because on some of the ones in my math lab, there's 3 lines and there's 1 line where the other 2 lines cross it twice, and if it's too crammed in, you can't see it. So that's why I say spread it out as much as you want. So if you don't spread it out the way I do, but you still get the right, the right answers, I'm good with that. So you just kind of spread them out how you want them. Okay, so my intercept 0, 18. So it's about right here is my 18. And again, I mark it so that I can see it. And then 6 is about here. And there's my, oh, please. Okay, there's my line. And then it's false. So Mark, it was Mark that asked this question, right? So you know how your 0, 0 is sitting right here? I don't want to shade that. So that's why I'm going to shade up here.
Gotcha.
Okay. All right. So that's the first one. Okay. So now do the second one. And in the chat, give me your intercepts. And we'll finish this one and then we'll take our break and come back and do word problems. I don't like that color. It's going to be confusing.
What do we need to find?
You're going to find the intercepts of the second line, this line right here,
Oh, okay.
just like what you did with the first one. Okay, so far we got good answers, good answers. So if your answers are there, good. Okay, so here we go. So I cover up my 2x, 4 goes into 32 8 times. And when I cover up my 4y, 2 goes into 32 16 times. Okay, and then 0 is greater than or equal to 32. That is a false statement. So I have 0, 8. So 10 is here. So 8's about here. And I have 16, 0. So 16 somewhere in here. Get my line. I have a false statement. So again, this is my 0, 0. I don't want to shade there. So I'm going to shade on the other side. Okay. And then we have one more line. So this third line, this is a line, right? This is, if you remember, anytime you have y equals a value, it doesn't matter what your x is, right? So if I have y is 20, it doesn't matter what x is. X can be anything, and my y will always be 20. So I end up with a horizontal line at y is 20. Okay, so that's how you would graph this. If it was x is 20, Then I'd put a point at x is 20, and it would be a vertical line. So remember, if it's y equals, that's your horizontal line. Okay, so now here is where the problem is. I can't say right or left. Okay, I can't say up or down. If it's a vertical, I wouldn't be able to say up or down. So with this one, I do the exact same thing. 0 is less than or equal to 20. This is a true statement. So I'm going to shade. So here's my 0, 0. I'm going to shade down here. Okay, so our feasible region is below the horizontal line. I have a corner point there. And all of this. That's where all the shading is. Okay, so my corner points, do it in, hopefully red will work. I have a corner point here, 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 and here. Those are my corner points. And if you notice, the shading keeps on going. So this is, and this is going to be important. This is an unbounded region, which means there is no maximum. You have to pay attention to that. If you have that's why you have to shade these, or you have to graph them. Even though it may not ask you to graph it, you still have to graph it. Because if it's unbounded, that means there's no maximum. There is a minimum, but there's no maximum. Okay. All right, so let's go ahead and finish this. So let's look at our corner points. So our corner points, we're going to get all the ones that we can get easily. So I have 0, 20, that's a corner point. And this is a little bit harder to see, but if I graphed it, it would look like this if I made it bigger. So here is 0, 20. Here is 18 or 0, 18. And then it goes down like this and then over like that. So there's a little space right here. That's part of the corner points. And again, that's why you want to spread it out so you can see it. So we have corner point, corner point, corner point, corner point. So remember, this is my green or my green x-intercept. Green x-intercept is 16, 0. Okay, so the only one I have to calculate is this one. That one right there. That's the only one I have to calculate. Okay, so that's the other reason why you always want to make sure that you're keeping track of your intercepts. Okay, so this is the yellow and green line are intersected. So I have 6x plus 2y is 36. So 6x plus 2y equals 36. And then the green one was 2x plus 4y was 32. Guess I should have done the colors. All right, so here we go. I am going to get rid of my y by multiplying by -2. So I get negative, so I get negative 12x minus 4y, and then 36 times 2 is 72. 72, negative 72. So I get negative 10x, that goes away. And then negative 72 and 32 is 40, negative 40. So my x equals 4. And then my y, I plug that back in. And check my math, make sure my math is right. 36 minus 24 is 12, and then divide by 2. So y equals 6. So when X is 4, Y is 6. So those are my corner points. And again, look at your graph. Does that make sense? So here is 5 is here. So 4 is backed off here. And then this is 5 here, and it's a little bit higher than 5. So I'm good. I'm in the right area. Okay, so there's my corner points. And then to find my maximum or minimum, we already know the maximum is not going to happen because it's unbounded. But we still have to check all of our corner points to see which one is going to make this objective the lowest or the highest. So 10 times 0 plus 20 times 20 is 400. 10 times 0 plus 20 times 18. What is that? 360. 10 times 16 plus 20 times 0 is 160. And 10 times 4 plus 20 times 6 is 40. And 120 is 180. Help me out. 40, so 20 times 6 plus 40. 160. Okay, so there's 2 places that have a minimum. All right, the reason why there's no maximum is because it's unbounded. There's no fence on this side. So it's just going to keep on going forever and ever and ever. So unbounded means no maximum. Okay, so our minimum value is at 16,0 and 4,6. We have a minimum value of 160, and I did that right? Yeah. And then there is no max because region is unbounded. Okay. All right. So any questions? All right. So it's 12:10. Come back at 12:20. We're going to do a couple word problems. And so it will kind of bring all this into an application. All right. Go ahead and take a break. Okay, so before we get started, are there any questions that you want clarification on before we move on? So let me share the screen again here. All right, we'll wait just 30 more seconds and then we'll get started. Sure, everyone, that I have everybody. Okay. All right, so I wanted to start this second half just showing you, what your homework is going to look like, because again, it doesn't ask you to graph it. So this is your first question. And remember, maximum or minimum only happens at the corner point. So this one, you have a feasible region inside the blue. Your corner points are 0, 0, 0, 10, and 10, 0. So that's what you're going to use to maximize this 4x plus 5y function. Okay, so there's no graphing on this one. Where I find students kind of fall apart on this is your basic question, right? Solve using linear programming, right? You have a minimize. So notice what you're looking for. You're looking for the lowest number, not both. Sometimes you're going to look for max, sometimes you're going to look for min, sometimes you're going to look for both. So always notice what you're looking for. And then the subject to, those are your constraints, right? That's the inequality that you're going to graph. The X and Y keeps it in the first quadrant. So you have to graph this and shade it in order to find your corner points, right? So if you notice, it doesn't say graph and shade, find the corner points, then maximize or minimize. You have to know that. You have to know that that's the sequence of steps, all right? So it's taking everything that you've learned, and now you're applying it into a linear programming problem, right? Now, when you get out in the business world, right, the whole point of linear programming is what's the maximum, what's the minimum? That's the whole point. So when you get out into the real world, right, you get into a job, if your boss asks you to find the maximum profit, often there are applications, there's technology that helps you do that. But learning it this way, now you can look at the technology and go, oh, I know what it's doing. I know what it's looking for. So sometimes jumping right to technology is not a good way to learn something. Jumping right to technology, you're learning to push buttons. Being able to graph it, find the corner points, see which one is the maximum and the minimum, actually helps you understand the process, right? Process is way more important than being able to push a button. And I think that's why a lot of students have come out of high school and all they know how to do is push buttons. So they haven't learned how to think through a process. So that's why this is such an important aspect of this class, is you're asked to do something in a very different way. And that different way forces you to go through a process. Okay, so again, here's another question. This one, you're looking for the maximum value. This is our objective function, the P equals 5x plus 5y. And then these are the constraints, the subject to. So now you have two lines that you're going to have to draw out, plus the restrictions. Okay, so your final answer, your answer will only be, what is your maximum value? That's the answer that they're looking for. But you have to walk through the process to get to that answer. Okay, so make sure you do that, walk through the process. Here's another one, same thing. Notice it doesn't say graph. It just says maximize or minimize. Okay, and then there's going to be 2 word problems, which we'll work on right now. Okay, so now we get to our word problems. So you've already done these, right? You've already worked through these. You can read a word problem. If you did your homework and if you did it over and over and over and over again, it should have gotten very easy to pull information out. Okay, so setting up a table is going to be crucial. Now, in the take-home test that I'm giving you, you have to set up the table. The table, well, one of them, the table is kind of set up for you, and the other one is not. You have to set up the table. Okay, so I give you one of each. All right, so here we go. We are looking at tense. We have the standard model, and we have an expedition model. Okay, each standard tent requires 1 hour for cutting and 3 hours for assembly. So what are we doing? We are cutting and we are assembling. Okay, we have standard tents and we have, what's the other term? Expedition tents. Okay, so the standard tent we're going to call X, the expedition we're going to call Y. All right. So each standard tent requires 1 labor hour for cutting and 3 to assemble it. The expedition tent requires, let me highlight these so that you can see where I'm pulling this information. So this is the standard tent. And then the expedition tent requires 2 from cutting and 4 for assembly. So 2 for cutting and 4 for assembly. And then the maximum labor hours in the cutting and assembly departments are 32 and 84 respectively. So 32 goes with the cutting, 84 goes with the assembly. Okay, and this is our maximum hours. All right, now here is what's different. So up until this point, up through 5.2, you've already done this, right? You've pulled information out and you've set up your table. And then we write our equations. So 1x plus 2y has to be less than or equal to 32. So this is our cutting equation. And then our assembly equation is 3x plus 4y has to be less than or equal to 84. So you've done all of this, right? What 8.3 includes is if the company makes a profit of $50 on the standard and $80 on the expedition, how many tents of each type should be manufactured to maximize the daily profit? Okay, so this part right here, let me get a highlighter here. This part right here is our objective function. Okay, this is our objective. Okay, so our P, profit, $50 on every standard tent plus $80 on every expedition tent. Notice there's no inequality. That's how you know which one is your linear equations or linear inequalities and which one is the objective. And we are looking to maximize. So we're looking to maximize profit based on these constraints. All right. And then of course we always have to have, because it's an application, we have to have our restrictions that only gives us positive values. So we have to have a positive number of standard and a positive number of expedition tents. Okay, so that's that pulling the information out. So again, the only thing new in 5.3 is finding the objective function, pulling that information out. And with the objective, it's always going to be real clear. We want to maximize profit, so the objective is the profit function. Okay, so here is kind of the steps to take. Let me make this a little bit smaller so we can see everything. So is that too small? It kind of is. All right. I'll try and you guys have better eyes than I do, and I can see it, so it's okay. All right, so here's kind of the steps that'll help you get through the process. Again, know why you're doing the steps. I just realized, let me make sure I'm recording this. Okay, it is being recorded. All right, so you want to pick decision variables, summarize the material, determine the objective function, write the constraints. So that's what these are. This is that subject to. These are what's holding us back, because this is an example of, I only have a maximum of 32 hours in a week in order to, or per day. I only have 32 hours a day in order to make these tents. In the cutting department. In the assembly department, I have 84 hours a day. So my question is, how many tents of each can I make based on the constraints of my time constraints? Okay, and then add non-negative constraints, which I did, and then use the linear programming or geometric method to do this. All right, so here we go. I'm going to write this down here so I can actually see it. So let me get my pencil back. All right, so I'm going to graph. So I'm going to do this one first. Okay, so cover up the X. My Y is 16. Cover up the Y, and my X is 32. And then test point 0 is less than or equal to 32. This is true. So I'm going to shade on the side where the 0, 0 is. Then I'm going to do the same thing for the other one. So I have 3x plus 4y less than or equal to 84. I'm going to cover up the x, and I get 84 divided by 4, which is 21. Cover up the y, 84 divided by 3 is 28. So this should be fairly easy, fairly quick, being able to do these two things. Okay, so here's my lines, here's my intercepts, here's where I'm going to shade. So my intercepts, my highest y value is 21. My highest x value is 32. So I am going to be able to put in my values. So let's see, 32. 21. So I'm going to go by 4s. And then my highest x value is 32. So I'm going to go by 4s again. And again, don't get bogged down on this. It's just a way to spread my information out is all. All right, so here we go. My orange line, I have 0, 16, and 32, 0. Okay, so here is where we can put in these applications. Remember what we said our X and our Y is. Our X is our standard. Okay, so we have standard tense down here. And our Y is our expedition tense. So that's what your numbers are representing. I have 32 standard tense, and I have 16 expedition tense. Those are my two values. So now I'm going to put in my line. Hold on. Oh, because I changed colors. That's fine. So I'm going to put in my line. Okay, I'm going to shade where the 0, 0 sits. So I'm shading down here. And I'm going to put in my non-negative restrictions. And all this does, oops, sorry. All this does on the, when you're actually doing it on paper, is it just reminds you to put them in when you get to my math lab. That's the point. It reminds you to put it in when you're in my math lab. Okay. All right, now I'm going to do the other one. So I have 0, 21. So this is 20, so about here. And 28, 0. That was probably a terrible choice of colors. 24 is about here. So there's my blue line. I don't like this for this. I need a different color. for my restrictions. Just because it's starting to get too color coordinated. Okay, so we can see I'm going to shade where the 0, 0 is. So I'm going to shade down here. So we can see where our feasible region is, right? Our feasible region is all in here. That's where the double shading happened. Okay. All right, so my corner points are going to be at the orange y-intercept, the blue x-intercept. So do you see how easy it is to find them when there's color? You don't even have to think, oh, which line is which. You just go back to your intercepts. I have the orange y-intercept and the blue x-intercept. And then the only other corner point is right there. So I have to do my elimination. So x plus 2y equals 32. 3x plus 4y equals 84. And I'm going to multiply, what do I want to get rid of? If I multiply by -2, yeah. And then I'll get rid of the y's. So I get -2x minus 4y equals a -64. So I end up with x equals 20. Okay, and look where my x is. My x is 20 is right there. This one was very accurate. Then I'm going to plug it back in. 20 plus 2y equals 32. And I plugged it back into the original. So my y equals 6. Yep, there it is. 4, 6, there it is. So we're super, super accurate on this one. All right, but notice I didn't go to my graph and find 26. I did the math. So when you guys are doing this test, I want to see everything, right? Every question on this subtest, if you will, the take-home test, there's multiple points for it. So like if question 1 has 10 points and part of it is showing me your elimination and you didn't show it, you're going to lose points. You may still have gotten the answer right, but if you didn't show every single part, then you're going to lose points. So just give me more than you think I need. Put it that way. Give me more than you think I need. All right, so here we go. So remember our objective, and I'm going to change this to P because we're looking for profit, was $50 for the X, the standard, and $80 for the Y. So 50 times X plus 80 times Y. Should have made these bigger. Okay, so I have my first corner point is at 0, 16. Second corner point is at 28, 0. Third corner point is at 20 and 6. And then remember, there's a fourth corner point, 0, 0, which is always 0, right? Just like what we did before, 50 times 0 plus 80 times 0. So this is an easy one to calculate. But when you're putting corner points into My Math Lab, make sure you include that if they ask for the corner points. All right, so here we go. 50 times 0 plus 80 times 16. So 80 times 16 is 1280. And then we're going to go 50 times 28 plus 80 times 0 is 1400. And then 50 times 20 plus 80 times 6. So 1000 plus 480 is 1480. And then of course we have 0. Okay, so remember, what is it asking for? It's asking for you to maximize. So we're looking for the highest value, which is right here. So this is my maximum. All right, so what does all this mean? Well, if you remember, the X is the number of standard tens. The Y was the number of expedition tens. So our maximum profit of $1,480 happens when I sell 20 standard tens and 6 expedition tents are sold. That's when maximum profit happens. Okay, now this is what I call an interpretation, right? This right here is called an interpretation. If you can interpret your answer accurately, you'll get extra credit. Okay, so it's not just about being able to do all the graphing and shading and, you know, finding the corner points and then finding the maximum. What does it mean? What does all this work? What does it actually mean? So like if we went to, and this is not the answer to this one, but if we went to our work, our My Math Lab, the way that you would enter your answer, so like on this one, you see how here's your maximum, here's your restraints or constraints. They did all the work. And then the way you would put in your answer is you'd say, okay, I have a maximum profit at, and this is not the correct answer for this one, but I'm just showing it to you, 1480. That's all you have to put in your My Math Lab. Okay, so it looks like you don't have to do a bunch of work, but you actually do. You actually have to graph it in order to get the answer that they want. Okay, so like on number 5, if they set the table up for you, then they say, okay, if the profit is 30 for trick and the slalom is 50, that's your or your objective function, right? So you're going to do all the work, find the corner points, and then plug the corner points into this function that says, you know, 30x plus 50y, this is our profit. And then whatever the maximum is. So when you read this, this is where you're putting in your values. So like on the one we just did, the maximum profit is 1,480. It occurs when we have 20 expedition and 20 standard and 6 slalom skis. So that's how you will enter the answer. And then when, hang on. Oh, sorry, it's over here. Then once you get this answer correct, there's 2 more parts to it. Now it's saying, okay, now what's the effect? What's going to happen if the maximum profit changes to $25 instead of 30? So then you don't have to regraph everything again. All you have to do is use the same information, same corner points to plug back into your objective function. But now with this one, the objective function is 25. It's 25 for the slalom. And then the trick ski stays the same. Okay, and then C, same thing. You're going to do the exact same thing. Corner points are already found, right? So you only have to do the graphing once. Corner points are found. Now, if the slalom ski increases to 40, so you're going to do 30 times the trick plus 40 times the slalom. So each question, A, B, and C, you're going to use the same corner points, just changing the objective function is all. Okay, does that make sense? Oops. Get rid of everything.
Yeah.
Okay. All right. So All right, so all I'm gonna do on this one is just set it up. And then when we come back on Thursday, what I want you to do is I want you to practice it, right? I'm gonna set it up for you here because we have enough time. And then once it's set up, then I want you to go through the whole process. Find the lines, find the intercepts, shade, find the corner points, use those corner points to evaluate your function. And then when we come back Thursday, I want to see what your answers are. Okay, so I'm going to have everybody hold up their work to your camera so that I can see you actually did it. All right, so here we go. We're just going to set this up. So hospital patient is required to have at least 84 units of drug A, 120 units of drug B each day. So this is our maximum drug amounts. Each gram of substance M contains 10 units of A and 8 units of B. Each substance of N contains 2 of A and 4 of B. Now, if there's an undesirable drug D, so now we're introducing another drug, 3 units per gram in M and 1 in N, how many grams of each should be mixed to meet the minimum daily requirement? Okay, and we want to minimize the intake of D. Okay, so there's a lot going on here. There's A's and B's and M's and N's and D's. But what we want to do is we want to narrow it down to, okay, what is it we're looking for? Okay, so whatever it is that you're looking for goes in here. It goes across the top. Okay, so we want to know how many grams of each substances M and N need to be mixed together. So this is M and this is N, right? And we'll just call this X and Y. We can keep it M and N if you want, but just because we're used to X and Y, we'll do that. What we put into the mix is drug A and drug B, right? So drug A is here. I need to make this bigger because I can't see it very good. There we go. Now I can see it. Okay, so drug A is here and drug B is here. Okay, so remember, what you're looking for goes across the top. Here is what we know. Okay, or what goes into the whole process. So like with the tents, the cutting and assembly is what goes into the process. Looking at the drug mix, A and B is going into the drugs. So now we can set this up. So drug M has 10 of A and 8 of B. So 10 of A and 8 of B. Substance N has 2 of A and 4 of B. So 2 of A and 4 of B. Okay, and because we're minimizing D, so we are going to, that is our objective. Because we want to minimize what D is. So D has 3 of M and 1 of N. So 3 of M and 1 of N. So here's our objective. Our maximum requirement. So of A is 84 and B is 120. Okay, so we have 10x plus 2y has to be less than or equal to 84. And then we have 8x plus 4y has to be less than and equal to 120. Okay, so I'm going to stop there. And then, of course, we have our first quadrant restrictions. That's always going to be there every time we have a word problem. Okay. And now you are all off and running. So here's our objective. Here are our constraints or subject to. And we're good to go. Okay, so now you're just gonna graph, shade, test 0, 0. You know, that gives you the shading. Find the corner points and then test those corner points with your objective function. And I'll put that here. So this is 3x plus y. Okay, all right, so I'm gonna stop there. We're stopping a little bit early, but what I want you to do is you can take these next few minutes to get as far as you can so that when we come back Thursday, we can finish this one and get the answer. Okay? So I'm going to let you go. I will see you on Thursday. And get into that My Math Lab. I'm going to start calling you out by name if you're not getting your work done on time. Have a good night, you guys.
Thank you, ma'am.
Bye, Miss. You too.
And if you have any questions, stick around and I'll be glad to answer them.
See you later.
Okay, bye-bye. Thank you, Franco.
Miss Manchester?
Uh-huh.
This Zoom, like the whole entire Zoom would be in the modules, right?
Not yet. I have to let it upload and then they let me know when it's recorded, when it's done uploading, and then I put it on the class.
In the class. Okay.
Okay, but it
Cause-
will be there. It'll probably be there by the end of the day.
Okay, perfect. Because
Okay,
I
and then,
just
Sophia, did you figure out how to do the restrictions?
yes, no, I did.
You did. Okay. All right. Very good.
I thought I was gonna be I thought I had to like press another button or something.
Oh, yeah. No, it's all just drawing lines. So,
Yeah.
Sophia, can I ask you, because this is the first time that you've waited until Monday to get your homework done. What did something happen this week that threw off your schedule?
It was just family came over and it
Oh,
was
okay.
just hectic, you know?
Okay. All right. Well, get on it because this tool that you're using is brand new. And so you have to use it often to get comfortable with it. Okay.
Yes, ma'am.
Okay.
And
that it?
yes, I remembered something. It was on one of the questions. It
Uh-huh.
was like use the quadratic method or something. Quadratic.
On one of our questions?
Yeah. Well, I don't know. I don't think it was on like anything that was due recently, but I think it was like when we were going through stuff during class. You know, maybe it was on the OneNote or something.
Yeah, it wasn't. No, we don't have any. Let me see. I don't think we've done the quadratic formula. I know we haven't. That's in section 2 or chapter 2.
Okay.
Yeah,
Chapter
no,
2.
we haven't done the quadratic formula yet. That's going to be not until, let's see if I can look at our schedule. Not until, well, we have solving quadratics by factoring. That's next week. Yeah, the quadratic functions isn't until module 10. So that's not till November.
Okay. But like the quadratic not the formula method. Was there anything that we've done like that?
Mm-mm. Not that
Nothing?
I remember.
Okay. Then yeah, maybe yeah, I don't know. Must have not been anything.
Yeah. I mean, all a quadratic is when you have x squared. That's a quadratic. So we haven't covered any of those yet.
Mhm.
That's after this next test.
Okay.
Okay.
And the test would be on like due on no October 29th, right?
Yeah, so the paper one that I'm gonna hand out, I'll open it October 22nd. And then you'll have a week to get it done.
Okay. I
Okay,
got
and
it.
that's on top of the homework. So, yeah, so that's where I really want to get you guys, working every single day so that you're not cramming it all in, because you can't learn anything if you're trying to cram everything in at the last minute.
Yes, ma'am.
Yeah.
And
Okay.
also one more question. I forgot. When are your tutoring hours or like days when you're here at NBC?
At NBC, I'm on campus Monday and